we are talking about the area of a sector that we're going to use radians for. So we've talked about the length of an arc. And so just a reminder, the sector is essentially like a piece of cake, the way that you cut a cake in slices or a pie. So you can see the diagram here. And if you have large and small sectors, then you have a minor sector and you have a major sector. So the green part is the major sector, the red is the minor sector. And you notice inside there is the angle theta that's inside the minor sector. All right, so obviously this, just as an aside in radians, this would be 2 pi minus theta, because 2 pi is a full rotation. So on a circle with radius r, the area of a sector with angle theta radians, and it has to be in radians, I'll underline that, is half r squared theta. Half r squared theta. So again, if we think back to how we used to do it, when you do use degrees, you actually have to build the conversion in. In degrees, it was a equals theta over 360 times pi r squared. All right? So we don't have to do that. It's just half r squared theta now, because of the fact that, imagine if you convert that degrees into radians, it actually builds that in. So let's have a go at a couple of examples. Find the exact area of a sector of a circle with radius 2 meters and angle subtended is pi on 3. Now again, let's just keep reminding ourselves, pi on 3 equals how many degrees? Well, we multiply by 180 over pi is a conversion, so that ends up being 60 degrees. You'll get used to that as we continue to use it. And exact area, so it can't be a decimal, we're going to use pi to do that. So if I was to draw the sector, and drawing a diagram is generally a good idea. So we have our sector here, something like this. The angle inside is pi on 3. The radius is 2 meters, so A is equal to half r squared, 2 squared, times theta, the angle inside, in radians, pi on 3. So that's half times 4 is 2, so it's going to become 2 pi on 3 units squared. All right, that's the exact. Now approximately it's about 2 units squared, 2.05 or something. But for the purpose of this, we just want the exact answer, 2 pi on 3. Let me put that in brackets up here. All right, so that's just a direct application of the formula. Let's have a look at the second example. A circle has a circumference of 185 millimeters, 18.5 centimeters if you like. Find the area of the sector cut off by an angle of pi on 5 subtended at the center. Now again, I'll remind you, this word subtended simply means the sort of angle in the center that makes that sector or makes the arc on the circumference. So what we're going to do is draw this. Again, always draw a diagram if it's not provided to you. It's a good habit to get into. All right, so we've got that. Now, again, I'm just going to look at this angle over here. Pi on 5 is equal to, well, what do we multiply by? We multiply by 180 on pi is what we do there. If we do that, 180 on pi, what's 180 divided by 5? It's going to be 36 degrees. All right, so that's exact, 36 degrees, which is helpful. So I'm going to write here as well, C equals 185 millimeters. Okay, now the problem with this question is if I draw my kind of sector, right, and I put my angle in here, which is pi on 5, which is exactly 36 degrees. The problem is I don't know what radius is, so need to find the radius. The radius, and that's where the circumference comes in. All right, so remember, C equals 2 pi r. So we know what the circumference is. Circumference is 185. So if we do this, therefore, 185 is equal to 2 pi r. So the radius is equal to 185 over 2 pi. And in this case, is millimeters. All right. So now that I've found the radius using the information from the question, circumference of 185. Now I can go ahead and find the area of this sector, which is what we want to do. Find the area of the sector cut off by an angle of pi on 5 subtended at the center. That's what we're doing. Pi on 5 in the center, we've got that area. So A is equal to, the formula is half r squared theta. So that's equal to half times 185 on 2 pi, that's the radius, times theta, which is pi on 5. Now, we could give, I might just give it in a decimal. Let's see how we go. We've got to be square millimeters. We might have to convert. So if we do that, let's have a look what we get. So we're going to have 185 squared equals, that's 34,000. We're going to divide that by 5. So 6845. That's squared over, now 2 squared is 4 times 2, that's going to be 8, and pi. And that's going to be units squared. Now, I don't think that's got any common factors, and it's not unit squared, is it? Because it's actually square millimeters. Now, if we remember correctly, a square centimeter, 1 square centimeter equals 100 square millimeters, because it's 1 square centimeter is 10 mil by 10 mil. So if I divide this by 10, divide it by 100, but then that's not so great. So let's just find what that is approximately. Divided by 8 pi, it's 272.35 square millimeters to 2 decimal places, which is equal to 2.7 square centimeters to 1 decimal place. All right, depends what the answer asks for. But as I said at the top, it's exercise 6.3. Give it a go here, and let's see. Ask questions if you need. Thanks.